This is new to you guys. And we're going to do this when we start studying algebra as well. Okay? When we do some operations with exponents, we can save some time by applying certain rules or laws. So let's say we have 7 to the 4th power times 7 to the 5th power. Okay? And yes, you could do 7 to the 4th on your calculator, 7 to the 5th on your calculator, and then use your calculator again to multiply. But you can make this a little bit easier. I'm going to write this out. So 7 to the 4th is 7 times 7 times 7 times 7 times 7. Seven to the 5th is 7 times 7 times 7 times 7 times 7. How could I write this whole thing as a single power? How many 7s am I multiplying? 9. Notice anything? Like if I said this, 5 to the 6th times 5 to the 3rd. How could you write that as a single power? 5 to the 9th, right? What happened to the bases? We just kept them the same, right? What happened with the exponents? We added them. That's one of the exponent laws called the multiplication exponent law. If you multiply 2 powers with the same base, so if I have some number x to the m times another power with the same base x to the n, that's the same as just writing the base one time and then adding the exponents. So when we multiply powers, base stays the same, add the exponents. What do you think happens when we divide 2 powers? What would we do with the exponents? Yeah, you'd subtract. Makes sense. So let's do that. Let's say we had 11 to the 10th divided by 11 to the 4th. Well, I'm going to write out 10 11s getting multiplied by each other. And then I'm going to divide that by 4, 11s getting multiplied by each other. Well, we can do some reducing. Those 11s cancel down to 1. Another pair of 11s cancel down to 1. I can do it with another pair and a 4th pair. And how many 11s am I left with up top getting multiplied? 6. So we can see the shortcut. If you divide 2 powers, they have to have the same base. Just keep the base the same and subtract the exponents. So if I said, so the exponent law, called the division exponent law, if I have a power with a base some number x raised to the some number m, and I divide by a power that has the same base and some exponent, that's the same as 1 power with base x, and then I just subtract the exponent. That's it. That's all. So let's do a couple of examples. It's really important that you read the instructions. Sometimes you will be asked to find the answer. Sometimes you will be asked to write your answer as a single power, which means we're not going to calculate it. We're just going to write this as a single power. How can I write this as a single power? 6 to the 9. Because base stays the same, add the exponents, and I get 6 to the 9. What would I do in B? Rummy? Now, like that?
No, but in bracket.
You need the parentheses. If there are parentheses around the original bases, make sure there's parentheses around the original answer. So this would be the same as -9 to 10 minus 6, -9 to the 4. These ones, notice the instructions say you're asked to evaluate. Okay? So what we can do is, before we evaluate, let's write it as a single power. How would you write that as a single power? What would you do with the exponents?
-2 in parentheses to the power of 11.
Because we add the exponents. Now do that in your calculator. And that should be 256, 5, 12,000, 24, 2,096. Am I right or wrong?
We got -2048.
Negative 2048. Oh, yes, 48, not 96. But is it negative?
Yeah.
Yes. We're multiplying an odd number of negatives, so the answer is negative 2048. Good. So we save ourselves a little bit of time. Instead of finding all these separately and then doing the operations after, can we write this as a single power? What do we do with these exponents? Add them, and then, so we would go 2 plus 4 minus 3, which gives me 3 to the 3rd, which you could do without a calculator. 27? 27 is correct. Okay. Okay, this last one. Remember, you can only put together into a single power if you're multiplying or dividing. I'm adding these ones here. I can't combine them. But I can combine these two. What is 6 to the 3rd times 6 squared as a single power? 6 to the 5, because I add the exponents. You cannot write this as 6 to the 7th because we're not multiplying them, are we? We're adding them. So we're going to have to pull out our calculator. And we're going to get 36 times, oh boy. That one's tough to do in the head. Anybody got it? Seven thousand.
776.
Okay, and now we have to add these two. So that's going to give us 7,812. Did I do that right? Yeah, 7,000. Okay, this one's a little complicated, but do it in proper order. I see stuff in brackets. So I'm going to look inside the brackets. I'm not touching anything else. Can I make that into a single power? Yes. What do I do with the exponents?
Use subtract.
Subtract. So I get -10 in parentheses squared. Can I do any other exponent laws? Could I multiply these two?
Yeah.
And get -10 to the
To the sixth.
to the 6th, because I add the exponents. -10 to the 7. Well, that's as far as I can go with the exponent loss, because this is subtraction. I can only combine if it's multiplication or division. So I'm going to have to pull out my calculator. Although you guys know how to do powers of 10 without a calculator. This would be positive because we're raising it, we're multiplying 6 tens, -10s together. And it would give us positive 1,000,000 because it'd be a 1 and 6 zeros. Minus, well, we could do this in our head. This is 1 and 7 zeros. $1,000,000 minus 10,000,000.
Minus 90.
Yeah, -9,000,000. Okay. There is one more exponent law, but we'll talk about that later. Okay. Okay.